All right, today we continue down our path of dealing with equations, and everything that was on the last test, most of it revolved around solving equations. Today we talk about solving literal equations, which deals with solving equations with multiple variables, and in most cases formulas with multiple variables. And when we shoulder partner today, we're going to verbally justify our steps. In other words, state what we did. Divide both sides by d or whatever. And there are many reasons why we're doing this, but in this class this year, it's because we really want to write equations that we graph in slope-intercept form because it's the easiest way to graph. So that's the reason why. So let's get started here. A little background knowledge. When we solve equations, we know the sorts of things we need to do. Sometimes we need to use the distributive property, and sometimes we need to use the subtraction property of equality, and then subtraction property of equality again, and then division property. So all of those things that we use when we solve an equation like this, those are the same sorts of things that we deal with or utilize when we solve literal equations. So here's our first equation, and I started with distance equals rate times time for a reason, and that's because in science you're going to use this little formula over and over and over again this year. So what we're doing is we're taking r times t equals d, and we want to solve for the letter in red. We want to solve for t. So how might I get t by itself? That's really what we're trying to do. How might I get t by itself? Mason?
Divide r by both sides.
Yeah, we have r times t. In order to undo the r times, we would divide both sides by r. So right now, this equation is d given in terms of r and t. And we'll work a little bit on phrasing things like that after a few problems. But we want to get t by itself. I want to get that by itself, so I need to get rid of the r. So in order to get rid of the r, once again, r times t, we're going to use inverse operations, and we will divide by r, which is the opposite or inverse of multiplying by r. And once I do that, I now have this equation solved for t. So t is equal to d over r. And that means that we now have t given in terms of d and r. t is solved for d and r. Okay? So, solving literal equations. You'll need to fill in something here. This is where we're solving a formula for a given variable. And the rest of what's up here you don't have to write down, but just listen. One of the dictionary definitions of literal is related to or being comprised of letters. And variables are sometimes referred to as literals. So solving literal equations seems to be another way of saying taking an equation with lots of letters and solving for one letter in particular. And that basically sums up what we're doing here. All right. I would like everybody to try number 2. So one of the things I did not mention in the last problem is we had F equals m times a. That's another formula that you're going to be using in science this year. Force equals mass times acceleration. This formula, of course, is the typical formula given to find the perimeter of any rectangle. One thing that I liked that time, and this is what I expect to see when you shoulder partner, is people helping each other out. That's one of the reasons why we do that. In this problem, we are trying to get L by itself. And one thing some of you may have noticed is that every time I decide which letter I'm trying to solve for, I put a little circle around it. And the reason why I do that is because that's the thing that I need to get by itself. One of the things that I heard a few of you talk about, you say, well, I'm going to divide by 2 first. Now, you could do that in this problem, but in many problems, that's not the best strategy. You should go in the same order that you usually would, with a two-step equation, which is really what this is. So what you should have done, really, in my opinion, is to subtract 2w from both sides. Now I have p minus 2w equals 2l. Now is the time where you really would want to divide both sides by 2 because I want to get l by itself. And if you're struggling right now with this idea, my advice, do what I'm doing here. Circle the variable that we're solving for at every point. So divide by 2, and we have L is equal to P minus 2W all over 2. There are other ways of writing that, like P over 2 minus W, but I'm okay with leaving it like that. So the original formula was P given in terms of L and W. Now we have L given in terms of P and W. Everybody try number 4. Autumn, what do you have?
I got B equals A minus 4C divided by 3.
All right, very good. Right now, A is given in terms of B and C. We should subtract 4C from both sides because remember, I'm trying to get B by itself if we want to think of it that way. So subtracting 4C is really what you should do first. Now we have A minus 4C equals 3B. Let's divide both sides by 3, which of course is the division property of equality. And we have B equal to A minus 4C. All of that is over 3. B is now in terms of A and C. All right, I would like everybody now to do both 5 and 6. Do both of them, please. Alicia, what did you get for number 5, please?
Q over C equals N, so Q is given in terms of C and N.
But Q is already given in terms of C and N. What is your answer?
Oh,
N is in terms.
N is given in terms of Q and C.
Very good. So we need to get N by itself. We divide both sides by C. And now that gives us N is equal to Q over C. So N is given in terms of Q and C. All right, number 6, Param.
I got D is equal to P plus 7C all over 5.
Okay,
D is written in terms of P and C.
very good. We need to get D by itself, so we want to add 7C to both sides and then divide both sides by 5. And that gives us D is equal to P plus 7C all over 5. And D is given in terms of P and C. So, let's continue on here. This problem, number 7, is really the real reason, one of the real reasons why we're doing what we're doing. Because when we are graphing linear equations, we want things to be in terms. Y is equal to mx plus b form, or slope-intercept form. And so in this equation right now, we want to take x minus 3y is equal to 8, and we want to solve it for y. So if I'm going to solve it for y, what should I do first, perhaps? And reality is this is not much different than what we just talked about. Yes?
Subtract X then.
Yes, that is a positive x, so we want to subtract x from both sides. And if you didn't know that, you should write down the correct steps. We want to get y by itself, so I subtract x from both sides. And now I have negative 3y equals negative x plus 8. Now some of you might be thinking, well, why didn't you write 8 minus x? The reason is because of what I've been hinting at when we've been correcting homework. I really want things in what is called descending order. I want to deal with the variables before I deal with the constants. That's the reason why I wrote it that way. And you should as well. Now to finish this off, Jorge, what should I do?
You would divide both sides by -3.
Very good. And so I want to get y by itself, use the division property of equality, divide both sides by -3, and now I really want to split that thing up. And I know I haven't done it in any problem previous to this, but the reason is because we want things to be in y equals mx plus b form. So some of you might be thinking, well, how did you get the 1/3? Well, I got the 1/3 because if I split this up, I really have negative x over -3 plus 8 over -3. And negative x over -3 is the same thing as 1/3 x. And 8 over -3, or plus 8 over -3, is the same thing as subtracting 8/3. That's how I got that. Any questions about how I went from here to here? Yes.
What if could we put it as negative x, or sorry, over 3?
What's that?
Could we put it as negative x over 3 or not?
But it wouldn't be negative x over 3. You had a negative over a negative. I just kind of showed you that here, which means it should turn positive, right? So could you put x over 3? So here's what Derek is saying, I think. He's saying, can you have this? Is this what you're saying, Derek?
Yeah.
That would be okay. But we really want to get in the habit of doing this for slope purposes, which we'll see tomorrow, okay? Or Wednesday. All right. Everybody do number 8, please. And could everybody write this down? The part in the yellow box next to number 7. It actually applies to number 8 as well. And I was hinting about that a few minutes ago, and I did actually mention it. But we want it like that because that's slope-intercept form, and that's very, very important when we are graphing linear equations. Once you have that written down, then continue on number 8.
Divide.
So once again, this idea of slope-intercept form helps us graph linear equations, and that form is sometimes referred to as y equals mx plus b. All right, Sam, what did you get for number 8?
Y equals 2 over 5x plus 3.
And that sounds right to me, and when I was walking around, that's what I saw in most papers. We're trying to get y by itself, so I want to add 2x to both sides. And remember, don't write that as 15 plus 2x because we want it in y equals mx plus b form. And so write it as 2x plus 15. Now divide both sides by 5. And we have, after I split it up, y equals 2/5 x plus 3. And once again, where did I get that? I got that because I split the 2x plus 15 over 5 into this. Kind of like working backwards with fractions. That's where I get the 2/5 x. That's where I get the 3 from. All right, so we've got a few problems left here. Now we start dealing with problems that have fractions in them. This, of course, is the general formula for finding the area of any triangle. And we want to solve for h. Now, any ideas on what we should do first, or what we could do first? Because there are many different things that you could do. I know what I would do, though, and it goes back to dealing with some equations that we've already talked about that had fractions in them.
Multiplying both sides by 2 or more.
Yeah. If you think about multiplying by common denominators, that will get rid of all the fractions within the problem. What is the common denominator here? It's 2. There's only 1. So if you multiply everything by 2, let's do that. Multiply everything by 2. In other words, you're multiplying both sides by 2. So what I'm saying is you're going to multiply this side by 2, and you're going to multiply this side by 2. Whatever you do on one side of an equation, you have to do on the other side to keep it balanced. So now, on the left-hand side, we have 2a, and on the right-hand side, we have b times h. I want to stop for a second and make sure that everybody's okay with that. Yes? Isn't it b times 2h? No, you're multiplying that whole thing by 2. 1/2 b times h is just one term. It's one term. Let me ask you this. What's that times 2? What? It's b. Okay. So when I put an h with it, it doesn't really change anything. It's now bh, or b times h. Okay? All right, I want you to finish that one. And of course, what's left is extremely easy to solve. What would it be? Okay, and that is, to me, the easiest strategy of dealing with these formulas or these equations with fractions in them. So we divided both sides by b, and we have h now in terms of, is given in terms of a and b, and so that's h equals 2a over b. All right, I would like everybody to please now do 10 and 11. Okay, in number 10, here's what I would have done. I would have multiplied both sides by 3. That way I don't have to deal with any fractions anymore. So that would give me 3v on the left-hand side and pi r squared h on the right-hand side. And that's the reason why the 1/3, if you want to think of it that way, disappears. So now I have this. I have 3v equals pi r squared h. I want to get h by itself. The pi r squared h means pi times r squared times h. So all we have on that right-hand side is multiplication to undo, if you want to think of it that way, multiplication, you divide. And I can do it all at the same time if I want to. So I'm going to divide both sides by pi r squared, and that leaves me with h equals 3v over pi r squared. So now h is given in terms of v and r squared. Or r, excuse me. All right, number 11, I want to clear out the 5 because I don't like dealing with fractions if I don't have to. The common mistake that I saw from some of you is you didn't multiply the 32 by 5 as well. You have to multiply the entire side by 5. In other words, you're multiplying everything by 5. So that would give me 5f equals 9c plus 160. Subtract 160 from both sides, which means I now have this, and then divide both sides by 9, and I have c now in terms of f. Any questions about either one of those? Now, number 12 and number 13 are only in your notes for one reason, and the reason is very simple, and you might want to make a little note to yourself. Word problems are going nowhere. We're going to continue to deal with word problems all year long. So that's the only reason that both of these problems are in here. Just as a reminder that we have to remember and recall how to take what we learn and apply it to word problems. In fact, I think both of these word problems were probably in a previous lesson. So that's why I'm calling it background knowledge. All right, we are finished for today. You have tonight's homework in front of you. Get your name on it. And you may begin.